This is a Geek Leader podcast, and I'm your host, John Rauda. This show is all about helping us grow as leaders, become better technologists, and improve our lives both at work and at home. I hope you enjoy the show and learn a lot. Welcome to a Geek Leader podcast. I'm your host, John Rauda. And if you could, please do me a favor and take a moment and leave a rating and review in whatever podcast player you're listening to this on, whether it's Apple Podcasts, Spotify, iHeartRadio, doesn't matter. I would greatly appreciate it. And that feedback really helps get other listeners to the show. Also, if you're not subscribed, go ahead and subscribe so you don't miss an episode. And if you feel so inclined, you can go to geekleader.com/tip and donate to the show. Thanks so much. All right, Geek Leaders, today I'm honored to have Toby Mills on the show. He is the founder and CEO of Entopy, and they are a leading innovator when it comes to supply chain and visibility and information and where that's going, using things like digital twin, which we're going to talk a little bit about today, which is, kind of a new topic for a lot of people in our audience, but I think it'll be interesting. We're also going to talk about some of the futures and things and areas where we see AI going in business and leadership decision-making. Anyway, with all that being said, Toby, welcome to the show.
Thank you. Hi, John. Thanks for having me on.
Yeah, if you don't mind, just tell the audience a little bit about your background and how you got to where you are today in your career and what your journey's been like.
Okay, yeah. So I've been an entrepreneur for probably 10, 12 years now. I sort of came out of the corporate management world. I absolutely hated that. Far too headstrong to sit in a room with a bunch of people talking about what we will do in 6 months' time. So I just sort of fell into entrepreneurship, and I've really followed my feet, to be honest. I've been very, very lucky to quite early on hook up with a couple of colleagues that are still with me. We still work together, and they're more technical. I'm more commercial, and just sort of following our sort of own journey through. So I haven't been to sort of the classic top university, had a wonderful idea at that university, fallen out of that and set a company up. I became an entrepreneur because I couldn't stand being in the corporate world. I've been very lucky to find some incredibly talented people to work with me along the way. And then, Entopy has sort of evolved into what we call an AI-enabled digital twin company now. But that's followed multiple pivots throughout our sort of life. So, starting life as a hardware software company in supply chain, and then we pivoted to become, focus more on the data orchestration space, and that's since become digital twin. So it's a very organic journey that I've had, I suppose.
So how would you define like digital twin for people that aren't familiar with that term? Because I think that's one of the biggest, areas that I see that is people just not having experience with what that means and how they can potentially use that.
Yeah, I mean, it's a term that's been hijacked. I think is fair to say. I use this. I sort of make a quip. I sort of say it's the most overused buzzword of 2024. That and AI, and we stick them we stick the two things together when we describe what we do. And look, in really simple terms, digital twin, it's a digital replica of a physical thing, process, or system. So if you can imagine data coming from the physical world, sensory data typically populating this AI model or digital model, that then reflects the real world through its design. It can then obviously update and reflect what's going on in reality, and then the data flows back to the physical world to affect the physical thing, process, or system. The kind of golden tests, there's two, for it to be a true digital twin. It has to be able to predict and simulate the future with accuracy. So you want this digital model to allow you to sort of tell you things that may or may not happen to the physical thing if they were subjected to X, Y, or Z. And the second test is that there's a two-way data exchange. So data comes from the physical thing, process, or system to the digital replica, and it then flows back. And there's therefore three sort of stages. You can have a digital model, which is a kind of flat, data just comes into it and it's quite static. It maybe doesn't update in real time. It's kind of a BIM model or something like that, if people are familiar with that sort of thing. If the data exchange is just one way, so data is coming from the physical world and just populating this digital asset, it's more of what we call a reflection or a shadow. And the twin is that kind of symbiotic relationship. But that's the kind of techie definition. But in really, really simple terms, it's a digital representation of a physical thing, process, or system.
So, there's probably a million use cases for digital twins, but I think one of the ones that just comes to mind really quickly would be like testing scenarios and going through like whether that be a vehicle you want to test like the crash rating of it without actually having to crash a whole bunch of vehicles, or the strength of a piece of a manufactured piece of equipment to see what the breaking point is, what the how much heat could it endure, and things like that. What are some other areas that are kind of that people are using digital twin models for?
I think you've cited a couple of really good examples. I mean, I said thing, process, or system quite intentionally. So a thing, maybe think about a component, like you said, a component of let's say a component of a car,
Okay.
a tire. And you've got this really, really cool tire design, and you want to test that. You want to test it for a bunch of reasons. Maybe you want to subject it to extreme heat. Well, you kind of want to do those things before you put it onto an actual car and put someone in it and drive around, right? So that's kind of a very typical use case, and people have been doing this for decades now. I sometimes say that digital twin is a mystical term that's kind of hiding in plain sight, because we interact with digital twins all of the time. I read an article a few months ago that spoke about digital twin Uberifying businesses. And that got me thinking, because if you think about Uber as a system, it's a bunch of cars driving around with drivers in them. Some of them are available, some of them are not. They all have a location. They're all updating, if you like, the digital twin of that system in real time, because they're providing data constantly. And then you, as a user of that service, you're also part of that system, and you're interacting with the twin via your phone. You're offering your location up. And of course, as soon as you then say, right, I want to hail that cab, I want to book that cab, that takes that cab out of the out of service. It affects the digital model. So there's that kind of two-way relationship. And if you sort of take that principle of Uberification, because I think that's quite a tangible term that people can relate to, and apply that to operational infrastructure, critical infrastructure, the shipping world, the supply chain world, the ability to see and understand what's happening in the physical world through this digital replica, but also be able to affect the physical world by either making changes yourself, or the actual twin predicting or simulating future scenarios and actually just automatically sending a message down to another system that changes the state. I think that kind of brings it to light. I mean, where Entopy focuses, we focus on what we call critical infrastructure. So when I talk about critical infrastructure, think about transportation systems, energy systems, cities, that sort of thing. We're heavy in ports and airports. So these are critical infrastructure in their own right. If they don't operate correctly, we don't have food on the shelves in our supermarkets. We can't travel internationally. And what we're doing with digital twin in those instances is we're essentially predicting aspects of that operation and providing that intelligence to operators, and predictive intelligence to say this is about to happen maybe 6 hours in advance, and that helps them to make better decisions. And so we're using digital twin to drive decision intelligence across critical infrastructure, and that's just basically helping operational and strategic guys make better decisions. That's it.
So can you give me an example of like how, like say, you're looking at a port, and what kind of information can you kind of predict using these? Is it like traffic? Is it there's gonna be too many ships there, or what kind of stuff?
It's all of the above. All of the above. I mean, we've got a few examples. So there's lots of different types of ports, right? So there's ferry ports. So here in the UK, we have a very famous channel that is between us and France. And about 30% of traffic from Great Britain to the about 40% trade between the UK and the EU goes through one of those ports. It's a ferry port, and they have a problem with traffic management, road traffic management, right? So they've got restricted infrastructure, restricted space, increasing demand. So digital twin in that particular instance can go in and start to predict future traffic volumes. It can predict when the traffic is going to spike. It can take into consideration all sorts of activity across the road network, roadworks and car accidents and so on. And if you can imagine, this goes up on a control operational dashboard in the port, and they can look at that and they can say, okay, well, in 6 hours time, this is what the traffic looks like. Or I'm looking out the window now, it's getting really, really busy, but actually the predictive intelligence is telling me that this is going to calm down. So I don't need to make any rash decisions right now. I can see into the future. On the other side, we're working with, I can say this one because it's public domain. So we're working with the biggest container port in the UK. This is the Port of Felixstowe. They account for 30 to 40% of containers into the UK. Here we're talking on the vessel side. So we're looking at huge vessels. So, I mean, the size of these things just staggers me, right? 400 meters long, up to 280,000 tons. So you've done a kilometer run if you run the circumference of one of these vessels. That's how big they are. And of course, they need assistance to berth or call at the port of any port, really. They need assistance to get there safely, right? So you can't have a monumental vessel like that, and you can't have that operation going wrong. We've seen very recently what happens when that does go wrong. And so there's an ecosystem of companies that surround that operation to help those vessels arrive at these ports safely. And there's two problems in that context. The first is congestion. So this is where we see the resources that are required to assist these vessels to berth, or the berths themselves not being available. And so a vessel will turn up. If you can imagine, it's traveled from Singapore. It's been on a 12, 13, 14-day voyage. It's arrived at its port of call, and it can't berth because the resources that it needs to assist it are not there. And this results in one of two things. Either the vessel drops anchor and it just stops and waits. It waits for that resource to become available, or it goes to another port. So in either case, in that scenario, someone's losing revenue and something's being disrupted. The other side of that, the other use case within that scenario is emissions, it's carbon, it's fuel use. So if that vessel has arrived and for whatever reason the resources aren't available, you have to ask yourself, could that vessel have sailed slower? Could it have sped up? Could it have optimized the time that it arrived to ensure that it had arrived just at the right time, used the optimal amount of fuel? And when you start to consider that global maritime shipping and the amount of carbon that sector uses is the equivalent of Germany, and we're collectively looking at ways to reduce our impact on the planet. There are real optimizations that can be made through technology like AI and digital twin. It's very, very tangible. It's very real. And that's what we're seeing. So hopefully that gives some color.
Yeah. So you could definitely you could check to see, and I guess with this, you can instead of waiting till they get there and saying, oh, what could you have done differently? Now you can tell them ahead of time, what you can do.
Yeah.
Yeah,
exactly. It's kind of a no-brainer.
Right. So how do you test these models to make sure that they're accurate? Because I think that would be one of the fears, is that you have a model that says, go slower and everything will be good, and then you go slower and you turn out now you're too late to get to the port and somebody else has already taken your spot, and
Yeah. So we're hearing loads about that now as well. With the adoption of things like large language models that had a real reputation for hallucinating, we're starting to see them used in not starting. They are being used now aggressively in real world context, and I've heard some. I'm not going to quote them because I don't know if they're true, but I've heard some stories. Okay, so what do? So we have this concept called micro models, AI micro models. So this is why we have the prefix of AI on digital twin. So what we essentially do is when we look at something like I've just described, you've got this huge system, you've got boats traveling from, halfway across the world, they're arriving, there's a bunch of other things that are happening as they arrive, and then there's a process of berthing them in. we look at that as a workflow, and then we break it down into the smallest possible component parts, the sort of smallest elements of that system or environment or operation. And we deploy very small, very focused, very targeted AI models, traditional AI models. So we're not talking about large language models here. We're talking about good old-fashioned machine learning algorithms. So we're talking, vector, SVRs, random forests, linear regression models, these sorts of things. And we're deploying them very purposefully at very, very specific problems. So we're reducing the size of the model. We're reducing how many features go into the model or the model is using. We're reducing, obviously, the amount of compute we're having to spend to train these models. And because they're so laser focused, the actual value that's output from each one of the models is limited. But what it does allow us to do is it allows us to look, almost micro, so closely at the performance of the model through the testing cycle that it makes the whole testing process quicker and more effective. And it allows us much greater resolution over what the model is doing. Then you have many of these, and they integrate into a digital twin. So you have this kind of network of models, of nodes, predicting very specific parts very accurately because we've gone through extensive testing, and obviously we've got much greater resolution because of the micro model approach. So we're really confident in the accuracy of each one of the nodes. They then feed into a digital twin framework. We hook all of this together with something called ontology. And then that ultimately feeds the insights somewhere out of the top. And then we put it into the real world, and we go through what we call a controlled release. Because we're dealing with critical infrastructure, you really can't take any chances. So we go typically at a sort of, it's normally manager level, manager or senior leader kind of level to have a first pass, and then we give it to a select group of operational folk to stress test it and give us that feedback. And we spend a bit of time just hearing that feedback, making sure it's okay before pushing this operational. And then once it is operational, we continue to monitor. So we have internal platforms that literally have, if you can imagine, like a dashboard of models that are all running the various jobs that they're hooked into. So you can see everything going on. You can see the performance. And we have the real world validation. The final thing I'll say on this is the validation data sets that we use. We try our utmost to find really credible validation data sets. And so we want to be, essentially testing the performance of our intelligence against commercial data, ideally. So data that's been used to generate invoices, or data that's been used to be quoted to an authority or like. So it's a complicated process, but the micro models technology, and I wanted to get that in quite early, this is kind of a center point of what Entopy does, and it plays directly to the point that you've just asked, which is about accuracy and trust in the data. It allows us to do that much more effectively than if you can imagine you had a 2, 3, 4 billion parameter model, and it's spitting out something that you don't quite understand. And now how are you going to decipher why it's doing that? How do you explain that output to the end user? How do you fix it? And it's hard, right? So by breaking all of this down into small, much smaller, much more focused pieces, it allows you to sort of look more closely, should we say?
Yeah, it sounds like there's the amount of data that you're actually using to kind of come up with these models could be very vast. I mean, especially when you're talking about like shipping, you're looking at, weather, current, type of ship, the weight of the ship, the fuel, and then all the other traffic that's around the ports and the other things that are going on. You mentioned like the ferry port and like car traffic. What if there's an accident? What if there's road construction? What if there's that aren't really related to the actual port, but maybe they're just off the port that's going to slow down, getting the goods off the ships away, and it makes the ships have to stay there longer.
I think like the traffic one is a really, I mean, yes, there's loads of data that we're hooking into, and I suppose this allows me to sort of quite neatly segue into some of the other benefits of the micro modeling approach. If there are so many different strands of things that you have to consider when looking at some of these problems. If you were to start by saying, right, let's go and build a map of all of the parameters that we need to consider, all of the things, two things are going to happen. One, you are going to take a long time trying to pull all of that data together. So before you've even started, you're going around beg, stealing, and borrowing data, not literally, obviously. But you are spending a huge amount of time, a lot of legwork, trying to get hold of data from various sources, and that really does take time. So you can't get a boat in the water, pun intended. You can't do anything until you've got all of that data because of the approach you've taken. The second thing that's going to happen is you are guaranteed to miss something. Okay, you are absolutely guaranteed to miss the fact that, oh yeah, it would be really, really good to understand what the weight of the vessel is, or it would be really good to understand how fast it's traveling. It would be really good to understand the tidal conditions. We need to, we need to consider geopolitical events. We need to consider global supply chain events. All of this stuff may come as an afterthought, right?
Yeah.
So again, the micro models methodology allows you to go iteratively. You can start and add to without having to rip it all up and start again. But the traffic example that you just pointed at, super interesting as well, because there are certain things within these environments that you simply can't predict. So we separate, when we were trying to predict traffic to the port entrance, we actually looked at this and we said, okay, well, what are the things we need to consider? Well, day, seasonality, weather, time of day. You need to understand, if there are any car accidents, that's going to be quite impactful. If there are any roadworks, if there are any school holidays, if there are any public holidays, sporting events, all of these sorts of things, right? And we sort of split it and we said, okay, well, what out of those things, what things are predictable? Okay, so what things have a kind of probabilistic sort of correlation almost, and what things are just completely random.
Yeah.
And very quickly we identified that car accidents must be treated as random. So instead of trying to predict car accidents, what we instead did was we put a network of micro models across a road network. So we went up as far as we thought it was relevant, and these models were simply predicting traffic flow based on day, time, weather, seasonality. That was it, right? And then what we did was we hooked into some real-time APIs, social media feeds, and so on, and we captured when there was, when there was an incident, basically, on the road network. We caught that in real time, and we integrated that as another node. It almost became, if you can imagine lots of dots on a road network, it became another dot. It became another node on that road network. And we had another model then that took into account the predicted flows and then the impact of this accident by understanding the severity and so on and so forth. And so the process goes on. So these models, the outputs from some models feed into the next layer above, which is a really, really important point. But again, it allows you to sort of look at the types of things you're trying to include in your model and make an assessment as to whether it's possible to predict that thing, whether it even makes sense to try and predict it, and treating things as I think in some cases they should be, quite individually. You can't. Who is it that said, if all you have was a hammer, everything looks like a nail? I mean, it's kind of very, very true in this world. You get data scientists coming to every single problem and going, right, AI will solve that. And it's not always the case.
So have you seen where like maybe generative AI or anything, like all the buzz and hype about that has like hindered some of the work that you've been doing? Or is it, like you mentioned the hallucinations that we've seen with Gen AI and some of the random things that, where, I've had, other industry leaders tell me that, AI is going to solve all the problems. And then you get there and it's like, well, maybe, but, but it's not there yet.
Yeah. I mean, all right. So I think generative AI generally has had a very, very positive effect on the whole conversation. I think that it's certainly got people. It's captured people's imaginations. I think when people first saw it, maybe they kind of saw glimpses of what it could do, and then made the jump to what they want it to do, and went through a period of maybe 6 to 12 months of realizing that wasn't quite the case. And so we've seen this huge excitement, huge wave of excitement, but then this kind of plateau. Well, it's the Gartner curve, isn't it? It's we're sort of troughing a little bit at the moment. The other thing I'll say about Gen AI is it is moving incredibly quickly. So, every week, every day, it seems a new model's been released that shifts the paradigm slightly. So, hugely relevant. I think it's generally had a positive impact. In my world, we see it as a tool, but we see it as having a very, very distinct positioning in that stack. So if you think about, so let me back up a second. One of the challenges you have with digital twin is you are building as I said, it's a replica of a physical thing, process, or system. So if you then consider that every thing, process, or system is unique, and particularly when you're talking about processes and systems in critical infrastructure, as we are, there's no port that's the same. There's no supply chain that's the same. There's no airport that's the same. They have the same workflows. They have the same function, but they've got different geographies. They've got different, and all of that has to be reflected in. Is this kind of front end development effort that is required with a digital twin. And one of the biggest barriers, I think, to adopting digital twin is exactly that. It's time to value and cost. So we've done a lot of things here at Entopy, like, a big focus of us is trying to reduce that at the front end and get to value quickly. And we've been quite successful in doing that. But where we see generative AI, particularly the sort of second iteration, the second incarnation of Gen AI, which is the agentic AI, where we see this, the kind of reasoning capabilities and so on, where we see that, or how we see that, is actually having an incredibly positive impact on our world, in the sense that you can put the Gen AI up as essentially an interface.
Mm-hmm.
And then that can interact with the structured data that's held within the digital twin, the traditional AI micro models that we have predicting very specific things with precision, and the open internet. And what that means is that in the adoption curve of digital twin, rather than waiting maybe 3, 4, 5 months to get to a point where the digital twin is operational, which, by the way, is very good, we're talking maybe weeks. So we're saying maybe we can come in and deploy a few models, connect a few, connect to the most relevant real-time data sources, connect to the open internet, and provide an interface. And then that provides that kind of wow factor to the institutions, stimulates the ideas and allows us to provide impact more early in that adoption curve, which accelerates things on the back end. So we see Gen AI as a tool. It's quite far up the stack from our point of view. We think digital twin and Gen AI is going to be quite symbiotic as it moves forward, because LLMs are only as powerful as the data they have access to. Agentic AI is all about these reasoning agents being able to call on various tools. Well, what is a digital twin? It's a suite of tools. It's a suite of structured data across an environment. So you can plug something like this into the top of it, and I think you've got something quite magical.
Mm. No, I think, I definitely see the, partnership between Gen AI and the digital twin, and kind of what you guys are doing there. And I think that's great because, I can foresee, once you create a pretty solid model and for a pretty solid digital twin, you could have a Gen AI then run, countless numbers of scenarios against that model and come up with kind of best case, worst case scenarios, most likely scenarios, and make better predictions by being able to run them, a lot faster than humans. And
but of course, the more you ask it to do, the more danger there is of it having a negative impact, just as you were sort of alluding to. So what's the impact of hallucinations? What's the impact of these sorts of things? So there's a huge amount of work going on in the industry. I'm sure your community is well aware of it, around putting appropriate guardrails around some of these kind of stick machines, because that's what they are. and trying to give them um, healthy guardrails. You don't want to restrict them too much. I mean, what one of the things we've seen is if you put kind of relevancy prompts on the front end of an LLM or a kind of chatbot architecture, just to sort of say, disregard anything that is not about X, Y, and Z. That's a way of, as kind of a catch-all for trying to limit the scope of what it will and won't answer. But that can go very much the other way, and actually you can get rid of some of the magic of this technology. So it's a careful balance. There's a lot of work going on in that area. I think, again, from my point of view, we're working in critical infrastructure. So the idea of our systems outputting false data is the biggest threat to our company, hands down. I said yesterday, it takes a year to build trust. It takes a minute to lose it, especially in this game where you're predicting future events and people are making really big decisions on it. Like you said, if we choose to speed this vessel, if we choose to slow this vessel down by 5 knots, we could save $100,000 a day. But if we miss the port call because we've slowed down and because the intelligence that we're acting on was incorrect, that's significantly more than any money that we're going to save. And actually, there's a knock-on impact. Shelves are empty, warehouses are empty. So there's real gravitas to kind of some of the decisions that we're enabling. So we spend a lot of time testing, looking at this sort of stuff, and trying to throw curveballs in, monitoring and so on. But the biggest thing that we do is we ensure there is always a human handoff. And we're very, very honest about where the technology is. So, of course, you can't 100% rely on human beings. One of the stories that I can't quote, but was to do with the fact that an LLM had spat something out. There was a human handoff, but the human just, turned a blind eye and ended up sending duff information through to so you can't always, but there has to be that human handoff. And I get into this debate with people all the time about AI replacing people and replacing operators and so on and so forth. And I honestly don't see it that way. I see it as a tool, as an empowerment, and that it's also absolutely necessary because of all of the risks, because of all of the downside of getting these things wrong.
Yeah, absolutely. And I'm the same way. I see GenAI tools, like the different ones that we use, as just being like, if I'm using ChatGPT to help me with, writing a paper or an email or something like that, it's more like a calculator for words, or whatever. It's just a tool that I can use to help me make myself more efficient and double check behind, my grammar, my spelling, and then come up with better ideas and ways of doing things. And same thing with like audio. I'll use an AI tool to kind of help clean up this audio before it goes out. That's going to, take out some of the ums and ahs and some of the background noises and things that you may hear that are going on to kind of smooth that out so it sounds more professional as it goes out. And I think that's where we need to focus on using some of the tools. But one of the questions I have is, what are some of the things that you see this going in the future? Like, what should all business leaders or tech leaders kind of be paying attention to when it comes to digital twins and AI to help them make better decisions in the future?
Okay, so I mean, like I said, the real easy point to make, and I'll come on. So the sort of technology lens. So if I think, before I get on to how people can adopt this to drive impact in their respective businesses, if I just look at the kind of technology and what's happening in the tech space, I think it's become very, very obvious in the past month and a half that the language model, the foundational model piece of the stack, is being heavily commoditized. And the value is, in my opinion, now certainly going to accrue in the application layer. And if you look at companies like Palantir, their stock went through the roof when the DeepSeek model was announced. And the sort of more closed models, they were squeezed. I think that the people that have the most powerful foundational models seem to own the distribution, and so they own the customers. And so where we're kind of building these things into our digital twins, we're building the LLMs into the applications. We're kind of looking at what's the best model, what's the best price, what's the best performance, and so on. We are absolutely agnostic. We don't care. And obviously the guys that have their own, they can drive it, so they've got really, really solid business models. But that area is being absolutely squeezed, and the value is, in my opinion, certainly going to accrue in the application space. And in terms of how people adopt AI, so there's one of I watched a talk from a lady called Kathy Wood just before Christmas. She's obviously a US investor, very famous, and she was talking about the mindset. So people looking at AI with an internet mindset, and I thought that was really profound as well. So she was saying, the mindset of the killer app is very much an internet mindset, and actually in AI, it's about how do I get AI integrated into a business. That's the killer app. It's how do you integrate AI into your organization. And of course, I think digital twin is a key part to doing that. But maybe she was intending to or meaning something else. I think when you then start to look at, I am an infrastructure owner, so if I go into my world a little bit now, and like me, and you're thinking, actually, do you know what? I could do with greater intelligence across my shipping network or my supply chain or my airport or my critical infrastructure. And I think what's really, really important is to identify, even if it's narrow, a very, very clear purpose first before you do anything else. The amount of people that I've spoken to that are saying we want to adopt AI or we want to adopt digital twin, and you say, why? And they say, because our board has decided that our company is going to become AI first. And you're like, okay, it's just because people are intuitively going, I'm either going to get disrupted or I'm going to disrupt. And the way I disrupt is by adopting AI. But they've missed the critical step of what's the point.
Right.
So you have to identify, do you know what I mean?
Yep.
You have to
100%.
identify your purpose. And then once you've identified your purpose, you can then start looking at the state of play. And the reason that part's really important is because you will almost certainly operate within an ecosystem. And then when you're operating within an ecosystem, oftentimes to get the value out of these sorts of things, you're going to need to share data across that ecosystem. So now you need to go and have conversations with your partners about, collectively going after this prize. But if you've got a very, very clear purpose, a very clear idea of how you're going to do that, it's much easier. And there may just be a sort of half step before that, which is just get something going, move past PowerPoint, move past slides, get to, MVP is the wrong term even. It's just get an idea of the purpose, try and prove that you can do that. So prove that the data exists would be a really good start, or prove that that insight would be valuable or have some substance behind it. Maybe get a very simple workflow, a traditional AI model. These things are not billions and billions to create, and they don't take years and years and years. We can create micro models in weeks. So you can deploy a micro model on a very specific part of the workflow, integrate that with a couple of other micro models and with real-time data. And to answer a very specific question, you've now proven an element of the purpose that you've identified, and that gives you the sort of ticket to go and coordinate. So it's not falling off a log. It's not easy. But I think far too often people kind of miss those steps and they jump straight to, how do I get GPT onto my organization without really thinking about what that's going to do? I mean, again, I've seen lots of chatbots that have been put up in front of dashboards to answer, what's on the dashboard. I mean, what's the point?
Yeah, absolutely. Yeah. I've seen the same thing. I've seen so many times where maybe a vendor wanted to sell me a chat bot to, help with help desk. Okay, well, that sounds good on theory, but then when you look at like, what are the solutions that you guys can help with? Oh, well, those aren't problems, like those aren't the real problems. Like, like reset a password. Well, there's a link to reset a password. It's right there. I don't need to ask a chat bot to go reset, I can just click the one link and I get a text message. Like I don't need this.
Yeah. No, I think that's I think that's exactly right. There's far too much innovation for innovation's sake going on.
Well, it's innovation to try to make money, right? Really, it's an innovation of trying to get that investor to say, "Oh, you're using AI now that you weren't using before, so we're gonna throw some money your way."
Yeah, I mean that's another thing that's super interesting. One of the areas that Gen AI has really hammered, um, somewhat ironically, is developers, right? Because I mean, honestly, the suite of tools that developers have available to them now. I mean, um, most most environments have a co-pilot. And I mean, I'll walk past my dev team and they'll be sat there with two or three co-pilots dotted around, bouncing questions around. One of my guys said to me, you know, I can do 2 weeks work in a day because of this stuff. So what that's doing is it's squeezing and, you know, whole labor markets really. It's opening up real opportunities. So, you know, I think the investor mindset, the reason I've just said that is because you were talking about investors and trying to get the golden egg to attract the money. I think that mindset's shifting a little bit as well because they're seeing smaller teams generate, you know, really, really sizable companies, sizable value. And you don't have to be a team of 500 engineers anymore.
Right, absolutely, yeah. And I was playing around with it because part of my background is app development and things like
Yeah.
that. And this has probably been a year ago now, or several months ago at least, where I was playing around with the early versions of ChatGPT and just having it help me with code. Before Copilot really was integrated with the Microsoft tools, and just being able to create very simple wrappers for iOS and Android apps, and it could do it so much faster than I could. And you still need that human handoff, like you're talking about. You need a human developer that understands the code and says, "Oh, there's some problems here," but it gets you such a head start that you didn't have before.
Yeah. Yeah. So there's 100% value in some of this stuff, right?
Oh yeah.
It's interesting where it's kind of happening, and obviously, you know, the developer role is because of that changing, right? So developers are now looking for, they are the smarts behind, if you like, every developer now has a, if you like, junior dev shadowing them pretty much all the time. You know, it's a bit like that. So, you know, it's definitely a shift. It's definitely a shift. I mean, are you seeing across your community, John? Because obviously you get to talk to loads more people than I do. But are you seeing similar sort of opinions to mine, or do you think Gen AI is going to continue to accelerate?
I think it's going to continue to accelerate, but I see like smaller teams, like what you were saying, smaller teams are able to do a lot more. And I think we're seeing that even like with recently Meta, they let go of like a whole bunch of developers and claim they're lower performing developers. But I think it's because their more senior developers have learned to use these tools and are able to, like it used to be, a developer was somebody that would take requirements and go just pound out code. Now, I think developers are more understanding of the business problems, using the tools to help them pound out the code and then solving the problems. They're more about problem solving than they are writing code.
Yeah, yeah, 100%. Do you think there's like lessons in that? Because when we were just literally talking about adopting it, so this is like a specific area, and it's an enlightened group, right? Because we're all techies. But if
Let me say it this way. So I teach part-time at Winthrop University, and I teach computer science. And one of the things I tell my students is that you need to learn these tools. You need to learn how to learn these tools. Don't just focus on like writing code. Don't you have to know that too. But it's more important that you learn how you learn and how to stay on top of the game and how you solve problems than how to write JavaScript. It's more important that you can develop the patterns and skill sets of staying on top of what's current today and how to learn those systems and tools. Like I just had an assignment where my computer science 101 students, which are mostly like right out of high school, to where they had to use ChatGPT to write code and solve problems. And they weren't allowed to like write the code themselves. It had to be all straight from prompts because I wanted them to learn how to put these prompts in there. Whereas maybe some more traditional professors are like, oh, you're not allowed to use prompts, but I see it the other way because, in the business world, I want my developers to be able to use these tools. because I know it's going to make
Yeah,
it
yeah.
efficient.
I completely agree, and I think there's a lesson in that for every professional in the world,
Yeah.
regardless of what profession you're in.
Mhm.
You know, what you're saying is that the guys that have been let go from Meta perhaps resisted this, and the guys that are there that are now kicking ass is because, you know, they've adopted these tools and that's leveled them all up. And
Yeah, and the same thing is true in the finance world, whether you're like, an accountant, if you can use these tools to make you more productive, or maybe if you're in the legal department, instead of just reading every contract word for word, develop a model or work with some developers or some teams to develop a model that will give you the parts of a contract that you need to really focus on, and the parts that are most likely to have errors in it, or most likely to not be in your favor. So you can focus on that to be more productive as you go through those systems. Um, medical world, same thing. Models that can detect, cancer or scans and can help you out with that. Or what are the, you know, one of the things that I've discovered is, I've torn my ACL twice in 3 years doing martial arts.
man. Okay.
And, the first time when it was repaired, they did what was considered to be one of the more standard repairs. And it's like just the way they typically do things. It was with an autograft. And the more I researched into it, there's a lot of data that shows that graft is more likely to fail based off of eh, you know, martial arts and doing exertions. Whereas a different graft may have been better, but my doctor probably wasn't using some of the tools that may show him that data, because he was just doing, this is the standard model for someone your age.
Yeah.
This is what we're going to do. Whereas like maybe we could have put more into, some type of modeling to say, someone that abuses their body the way John does, maybe he's, has a little bit stronger graft here.
Well, yeah, I mean, are you a sportsman then? Sorry, we're going off.
Yeah, not a good one, but yeah. But yes, I enjoy activities. Yeah, my children and I do martial arts, and all my kids play sports, so we're
Oh wow.
active. Yeah.
I mean, like, so I think just sort of circling back to the kind of skills thing and thinking about that. I mean, me as a sort of startup founder, I'm looking around. Obviously, one of my biggest responsibilities, one of the biggest ways I can affect the company is who comes into that company, recruitment, right? And I suppose I'm now starting to adopt a bit of a mindset of employing the person as opposed to the skills. We brought someone in about 2 years ago who has zero marketing experience, zero events experience, and she is now running our social media. She's running all of our events. She, ran she runs online events. She runs trade shows. She runs absolutely everything, whilst making sure that we have good, high quality social content going out every week, blogs, all sorts of stuff. She's like a one person marketing team who's got zero experience, but she's learned how to use AI.
Yeah.
Do you see what I mean? So,
Yeah,
and
absolutely.
we employed her on employed her on her personality and her approach, and and then she's proved us right by adopting AI. So I think that's a real lesson that I'm taking as well.
Yeah, absolutely. And, I couldn't agree with you more on how, how these tools are changing business in general. And I think that's one of the areas that we definitely need to focus on in the future. Toby's been a great conversation. How can people connect with you online, learn more about the things that you guys are doing, and maybe stay current, maybe join some of the webinars that you talked about putting on,
Oh yeah.
and learn some more?
Yeah, no, I'm pushing that, John. I'm pushing that. So we're at entopy.com. That's entopy.com. It's entropy without the R. You can find us on LinkedIn, X, Facebook, Instagram, on all of the various social media channels. And I think we're up on YouTube as well. We post a very regular blog, and we're quite active on those social channels, so you can sort of keep up to date with what we're doing there. And we do attend some physical events, in-person events as well. We're at Big Data and AI World on the 12th and 13th of March, which is in London at the Excel as part of Tech Show London. So if any of your audience are in the area on the 12th and 13th of March, it's a free event, and swing by. You won't miss us. Our stand is incredibly loud. So feel free to reach out and continue the conversation.
Awesome. Sounds great. Thanks so much for coming on the show.
Pleasure. Thank you.
Hope you enjoyed the show. Please go to geekleader.com to learn more about what this guest is up to, click on their links, and connect with them online. I would also greatly appreciate it if you could leave me a rating and review in Apple Podcasts or wherever you listen to the show. And make sure you've subscribed if you haven't already. And if you feel so inclined, you can leave me a tip by going to geekleader.com/tip.